Thank you for joining me. Good morning, folks. So this talk is titled The C4 Model, Misconceptions, Misuses, and Mistakes. If that sounds too negative for you, the other way to think about this is the advanced stuff around C4. I see a lot of people trying to adopt a new C4, but they're struggling with certain aspects, and I'm going to tell you about some of those certain aspects. For those of you who might not have heard of the C4 model, I'm going to do a really quick intro so we all have some common understanding here. So what is the C4 model? I've spent my time traveling around the world and looking at architecture diagrams, and most of them are horrible for a whole bunch of different reasons I'm not going to get into today. A lot of people have previously used UML to draw architecture diagrams, but that's not the case today. Why are people not using UML? I've literally heard of these possible excuses, and these are excuses. So that leads us to an interesting situation. People want to draw diagrams. They don't want to use UML, so they kind of fall back to boxes and arrows. And of course, there's a bunch of issues with doing so. So I created the C4 model essentially as a way to bring some structure into the typical ad hoc boxes and lines diagrams that people draw when they're trying to describe their software architectures. The C4 model is essentially based upon a set of 4 hierarchical abstractions. We have software systems, containers, not Docker, I'm sorry, I got the name first. Containers and components and code. So a software system is made up of one or more containers, applications, and data stores. Containers contain components, so this is a grouping of related functionality, nice, clean, well-defined interface running inside a container, and components are built from code. So it's a set of 4 abstractions, and then you have a set of 4 hierarchical diagrams that map onto those 4 levels of abstraction. So C4 is actually named after the diagram types. It's context, containers, components, and code. And really the concept here is diagrams as maps. So I live in Jersey in the Channel Islands. If you do a search on Google Maps for Jersey, you'll get that picture. That's great if you want to know where the airport is and where the main town is and how to get from one to the other. If you don't know where Jersey is because you've never seen Bergerac as a child, it's too much detail too quickly. I knew there'd be a few of you. So you can do the Google Maps pinch to zoom out thing to get some more context. On the flip side, you can zoom in and eventually drop into Google Street View, which is a one-to-one mapping with the real world when the photos were taken. And I want to do the same thing with software architecture diagrams. I want different levels of diagrams that allow me to tell different stories to different audiences. I'm going to explain the top 2 diagrams very briefly. So the first one's a system context diagram, and it shows you the system you are focused on, describing, designing, and the world around it in terms of people and other software systems. So therefore, in order to draw a system context diagram, this is the set of questions you need to ask. What's the scope of the thing we are building here? So what features sit inside, what features sit outside? Who's using it? So who are the actors, roles, personas, real users? What sorts of things are they doing? And what are the system-to-system integration points? Answer those questions, and you can draft up a system context diagram. So the red box in the middle is the thing that's being designed here. This group has identified a couple of user types and a bunch of external existing systems in the environment. We do the pinch to zoom thing on the red box. Now we can drop down to level 2 and draw a container diagram. A container diagram requires a different set of questions to be asked. So what are the major technology building blocks in terms of applications and data stores? What are the responsibilities of those building blocks? What technology choices are there? And how do these building blocks communicate? Answer those questions and you can draft up a container diagram. So now we've zoomed into that red system box and we're now showing the applications and data stores that make up that software system. So that's the really quick intro. I've had a lot of people say this to me relatively recently, so I've only just heard of C4. I guess it's new. It's actually a lot older than people think. So I tried to figure out the exact kind of time that this was created. And as far as I can work out, it's somewhere around 2010, which might surprise some of you. So I did a talk at QCon London. And although the C4 naming was not necessarily here at the time, you can see the concept is here. There's like a wide angle view of your system, a telephoto view, and a macro view kind of zooming in on the code. A few months later in London, I did another talk, and we can see that the C4 names have started to make an appearance. In this case, it was context, containers, components, and classes, because I was mostly focused on Java and C# stuff. The C4 name itself came about in around 2011. So this is when I came up with that acronym. And then over the years, you can see some of the other concepts kind of start to emerge and evolve. And somewhere around 2018, which was when I think the C4 website was created, classes changed to code to make it a bit more generic. So it's been around for a while, lots of usage out there. People ask me why I reinvented UML. I don't think I have, actually. C4 wasn't designed to replace UML. C4 was actually designed because people were not using UML. So I was teaching people how to do architecture. I was teaching people how to draw software architecture diagrams, but they didn't want to use UML. So I thought, I'll just teach them how I do this. And that's essentially the background behind the C4 model. If you break C4 down into its constituent parts, it's actually very simple. C4 is a set of hierarchical abstractions. There are 4 of them. The set of hierarchical diagram types, there are 4 of them, plus some other diagram types I'll mention later. It's notation independent, so I'm not dictating a notation here, and therefore it's also tooling independent. So that's C4 in a nutshell. If you believe this is true, which I do, it's not a large jump of the imagination to say we could take C4's abstractions and diagram types and use UML as our notation. Nobody does this because they don't want to use UML, but in theory you could totally use UML or SysML or Archimate as your notational elements here. One of my pieces of advice around C4 is don't feel that you have to use all 4 levels. So most organizations use the top 2, the system context and the container levels. They are quick to create, they give you lots of bang for your buck, and they're not that volatile. Once you get down to levels 3 and 4, these are much more code-focused levels. Every time you add a feature, you potentially now changing those level 3 and 4 diagrams. So hence the advice, use levels 1 and 2, use the others if they make sense and there's some value there. So that raises the kind of interesting question. If you're only recommending people use the top 2 or maybe 3 levels, why not call it something else? Like C2 plus 2 or C3 plus 1 or some other weird combination of C's and numbers. The answer is grounding. So I presented you very briefly the set of abstractions behind C4. We have a way to get from very high-level software system abstractions through a bunch of layers down to the code at the bottom. If I remove the bottom 1 or 2 levels of abstraction, what you've now got are 2 high levels of abstraction somehow floating around but not quite connected to a code base. So I really like the traceability that having this set of abstraction provides. It provides a way to go top down and bottom up and have traceability and reduce the model code gap and all of these good things. But you don't, of course, have to draw diagrams at those levels. So that's why it's still called C4. Notation. I get a bunch of questions around notation. People tell me that the blue and gray notation is boring. Oops. I think this is my fault, but I'm not going to apologize for it. So in order to draw some example diagrams for the C4 website and my workshops, I had to choose some colors. I chose blue and gray. That's it. As I said before, the C4 model is actually notation independent, so therefore other colors are available. Now the problem here is many tools have adopted C4, and what they've done is they've copied my look and feel of my example diagrams. And that's why when you go to C4 Plant GML or the draw.io templates or any other tool, they have the same blue and gray shapes. So those diagram examples do still exist. The blue and gray examples are still there in my slide set on the C4 model website. However, if you go to the C4 model website and you refresh the page, you might get different colors. Now, I do apologize for this. This annoys people because I'm sure I was looking at a green diagram a second ago, and now it's red, and I don't know what's going on here. That's my fault, and I apologize. But this whole thing about C4 is boring because it's blue and gray has gone away. So that's a win. Some of the C4 diagrams look very wordy, they look very verbose, and I've seen some criticism online that says C4 is unclear because it forces you to put more text in the diagrams. So I like to flip this on its head. The reason I'm adding the text to the diagrams is actually to solve a bunch of issues around ambiguity. So here's an example diagram. It's very typical. It's just a bunch of boxes with 1 or 2 words in. If you were to study this intently and then I ask you, what do you think the file system does? The literal only answer you can suggest is it stores files. Hooray, thanks. Like having a box labeled file system is not a good idea. Please do not do that. But that's why I'm adding the words here. I'm adding the words to indicate responsibilities or features or data types being stored. So now we can say that the file system is storing search indexes. So that's why I'm adding the additional text. It's really to provide an at-a-glance view of what's going on here. And of course, the software systems that we build have feature. They have function. When we look at a set of floor plans for a house, it's obvious. But with software architecture diagrams, it's less obvious. The trade-off here is the diagrams are wordy. And I get that. So my advice here is keep the words as short as possible. Single sentence, 3, 4, 5, maybe 6 bullet points if you have to do it that way. If you require another version of the same diagram for doing a presentation because you don't want people distracted by the text, just turn that extra detail off. So for me, this is now a tooling issue. What you want is you want some tooling that can just turn this detail on and off. In Visio, this is a real pain because now you have to copy paste the file and double click in every box and remove all the text and then recenter everything. So for me, this is now a tooling issue. We're just showing different versions of the same information at different levels of detail. On a similar thought, I've heard a few people say this. We found the metadata was getting in the way. What do I mean by the metadata? On the C4 diagrams, you'll see it says the name, and then it has this is a container or this is a software system, and it's got some tech choices in there. Again, I really like this because it removes a lot of the questions around abstraction level. So if you have a box with a name like, what is this? Is it a thing we deploy, or is it a system, or is it something in the code? Having that additional metadata, I think, really helps here. But again, a lot of people kind of find this cluttered. You can remove the metadata, but now I think we're back to square one. You know, if you've never seen this diagram before, it's not obvious what the deployable parts are. What are the applications? What are the systems? We've lost that additional metadata. We've lost those abstraction types really being shown on the diagrams. So my recommendation here is keep the metadata if possible. Viewpoints. People tell me that C4 is not good at showing decisions. Is the correct answer. It was never designed to. And architecture diagrams shouldn't show decisions either. Architecture diagrams show you the outcome of the decision-making process. Right, all of that design work you do in your teams collaboratively, the diagrams show the outcome of that. So that begs the question, how do you document decisions? And the answer is ADRs. Right, it's pretty straightforward. You have a set of ADRs and a set of architecture diagrams. There should be some relationship and traceability between these two things, but essentially keep these artifacts separate is my advice here. People tell me that C4 omits the deployment story. And again, I think this is somewhat my fault. C4 is named after the 4 static structure diagram types, but you do need other diagram types like deployment to tell more of the story. So the C4 model itself was inspired by some of UML and some of Philip Cruikshan's 4+1 model. In 4+1, you do have a bunch of different views of the same software system, one of which is the physical view here. So therefore, when you go to the C4 websites, there are a bunch of supplementary diagrams described. One of those is a deployment diagram. And the deployment diagram in C4 allows you to show the mapping of C4 containers, so applications and data stores, onto things in the infrastructure world, like servers, Docker containers. So if you have like a Spring Boot app and you're deploying it into a Docker container, there's actually a really nice one-to-one convenient coincidental mapping between a C4 container and a Docker container. And that's what these deployment diagrams allow you to do. You can also draw your typical cloud architecture diagrams with all the nice AWS, Azure, GCP icons, etc. But again, using the C4 concept and mapping C4 containers onto your cloud infrastructure. The problem with defining 4 levels of abstraction is that many people are going to say it's not enough for them, for reasons around scale complexity, and so on. And I've got 2 takes on this. The first is this. This is a lot of words, but this is from a blog post about something called concrete diagramming. And it starts off, the problem is that systems today have many different kinds of things. I agree. Servers, databases, virtualized containers, APIs, pipelines, repositories, packages, libraries, and all the other stuff we build. And really, the summary here is, how do we force all of these things into C4's abstraction? The first point here is that many of the things in that second sentence are deployment aspects. So I think step 1 here is make sure that in your mind you separate out what are the static things in my software architecture and what are the deployment things. And don't forget that deployment things will vary depending on your deployment environment. Your development deployment environment is going to look vastly different to your production cloud architecture deployment environment. So that's why I'm a big fan of keeping the deployment stuff separate from the static stuff. So to go on further, in that same article is this quote, "A database is a database. Debating whether it is also a C4 container or a C4 component just isn't worthwhile." And it's at this point I do disagree. A database is a database. What's a database? Is this referring to a database server, a database schema, a collection of data, a collection of tables? The word database is just too vague in many situations. For example, you'll hear a lot of people say this: microservices should not share a database. I'm happy for multiple services to store data on a single Oracle rack cluster in the organization, a single database cluster, a single database server. I'm less happy if multiple microservices are sticking data in the same relational database schema, where you can potentially do joins from one service's tables to another service's tables. So I think something we need to do here is be much more precise with the terminology that we're using. And actually, that's what this whole C4 thing gives you. Trying to map your static structure elements, your static structure building blocks onto the systems, containers, components forces you to think. It forces you to have some conversations. What is this thing? Is it being shared with other things in the organization, and so on and so forth? And that's actually what leads me to this statement, the power of C4. The diagrams are super useful, don't get me wrong, lots of people love the C4 diagrams, but the actual power behind C4 is that small set of named abstractions. It allows teams to align their mental models of the systems that they are building. And you don't have to take my word for this. There was an article published on InfoQ in July this year, and it turns out Decathlon are using C4, which I didn't know. I've never been to visit them. And there's this one block in the interview, and it says this: the C4 model is inherently declarative. Not sure about that. It requires teams to address and synchronize their mental models of code, components, containers, and the context of applications. So that's really people saying, yeah, this is about synchronizing mental models both within our team and outside of our teams, which is pretty cool. So that's kind of thread 1 with the C4 thing is too limiting. There's a set of tooling out there called Like C4. And when you go to the Like C4 homepage, it says this: inspired by C4 model and Sturcturizr DSL, which is my own tooling, but with some flexibility. You define your own notation, I can do that too, custom element types, and any number of nested levels in the architecture model, perfectly tailored to your needs. So essentially what this is it's like my Sturcturizr tooling, but it allows you to have more than 4 levels of abstraction. And you can define and customize what those levels of abstraction are. And this sounds wonderful for a bunch of reasons. Number 1, C4 seems too limiting with just 4 things. I want to add more things because our organization is unique and special, and we have a certain scale and complexity that C4 can't cope with. More about that later. So this seems appealing, right? This seems to remove all of the rigidity of C4 and give you some freedom. The problem is, and this is the example from the Like C4 website, what does this mean? So we're defining a service which has components inside it, and then those components have more components inside those. So we have two levels of components nested. I don't know what this means. This is exactly the problem UML has. A UML component is described as a modular unit that's replaceable within its environment. It's the same thing. I don't know what this means from a software development perspective. Someone posted an issue about some sort of bug in like C4, and the example they used to reproduce the issue was this. Like even more levels of nested components. The fact that you can do this in a domain-specific language to describe software architecture kind of bugs me. So let's step back for a second. What's the point of this? Again, it's to try and remove the rigidity around C4 and then having those four levels of abstractions. So 20 plus years ago, people are doing ad hoc boxes and arrows. I kind of come along and go, right, let's put some structure around this, and I defined a bunch of abstractions, and that's essentially where C4 comes from. And now people are saying, well, C4 is too rigid. We want more flexible abstraction levels. So in theory, it sounds like concrete diagramming and like C4 are taking you even further and kind of improving the experience by adding the ability to be much more flexible. The problem here is it turns out defining abstractions is really hard. Trust me, I've only got 4, and I've had to constantly revisit the definitions of those 4 levels of abstractions to try and answer all the questions I've gathered up over the 10 or 15 years I've been teaching C4. If you're not willing to put the effort in to properly define those additional flexible abstractions, I think what actually happens is rather than extending this thing, you go round in a circle and get back to what you had before. Right? Any degree of ambiguity in your new additional abstractions takes you back to the start. So that's my cautionary tale about feeling that C4 is too limited. Why is C4 too limited? It's because I think people are mixing concepts in their mind, and they're trying to define everything as abstractions when perhaps some things are best suited to being organizational structures rather than abstractions in their own right. So people ask me, what are my thoughts on modeling additional abstractions? And so the sorts of things they're trying to model are subsystems. So if you have a gigantic monolithic software system, you might want to create a simpler diagram showing the subsystems that exist in that system. I don't think this is a particularly useful diagram. Bounded contexts. So if you have a single monolithic system which is covering a whole bunch of different DDD bounded contexts, the lower level diagrams look horrendous, so let's draw a very simplified version showing the various bounded contexts and how they interoperate. I don't think this is necessarily a useful diagram either. And layers. Right, you have a gigantic monolithic application, and the detail looks complicated. Let's draw a simple version with layers, because it removes all of the clutter. Again, I don't think this is particularly useful either. So I'm not saying that these concepts, subsystems, bounded contexts, and layers are not useful. I'm saying I don't think they are abstractions in their own right. I think they're really organizational constructs. And perhaps that's a better way to think about these concepts when you're drawing something like a C4 architecture diagram. So with the layers example, imagine we're building a Java, Spring Boot, Spring MVC web application, and we have a whole bunch of components, and those components are organized into architectural layers. We have like a web layer and a business or service layer and a data layer. So in this example of the diagram, I'm showing you we have a couple of services represented as components, a couple of repositories represented as components, and I've drawn a dashed line, a dashed box around these things to say the stuff in here is the service layer. So now we're now showing components organized into a service layer, similar with the repository layer. If you want to show that those repository components come from a particular build time module, like a jar file, you could do that too. So I think I'm using layers and module boundaries here as organizational constructs on top of the C4 abstractions. And we'll see this concept pop up again in a second as well. Message-driven architectures always gets people. So how do you draw message-driven architectures with C4? It's very tempting to draw this. So we have a bunch of services pushing messages into a message bus, and those are being forwarded on to a bunch of other services on the right-hand side there. This is not the best approach for modeling message-based architectures with C4. Why? Because you get a hub and spoke architecture, everything goes in, everything comes out, you can't see the real detail here. Notice I'm trying to represent the message bus as a C4 container. So RabbitMQ or Kafka, I'm trying to model that here as a C4 container. That's the incorrect approach, hence the little X in the corner. So how would I do this? I'd probably do it like this. Imagine that service A has a point-to-point coupling via a queue called X to service C. I'm going to draw it like that on the top. And maybe there's a similar point-to-point coupling between service B and D via another queue called Y in this case. So what I'm doing here is I'm treating the individual topics and queues as C4 containers. Why am I doing this? A C4 container is an application, no, or a data store, yes. An individual queue or topic is a data store. It's a bucket, something sticks messages in, and one or more processes pull messages out. We can now separate our static view of the world from our deployment view of the world. So if I was building this, at development time, I might have both of these queues on a single RabbitMQ broker on my laptop. At deployment time for production, I might have cluster 1 for QX and a separate cluster, maybe even in a different AWS region, for example, running QY. So I think this nicely fits in with a lot of the other advice I've already given you as well. If you generally have a point-to-point coupling via a queue or topic, and it's a one-to-one, you could argue that that just adds clutter. You know, we've got these extra queues and topics in the middle. Why not just draw the arrow between the services? And you could do. So one of the things with C4 diagramming and modeling is there's often not a single correct approach, but you have multiple approaches which are all kind of the same, but they just vary in terms of visual clutter, visual noise, and simplicity. So this one's fine too. So now we have a point-to-point coupling. We can see that one-to-one mapping between the various services. And I've added via QX on the arrow. So this is a much simpler notation from a visual perspective, but the whole topic queue thing is a bit more implied and implicit. Some people like the first version, some people like the second version. They're both fine as far as I'm concerned. If you have so you'll notice all the arrows so far have gone from the left to the right. If you have more of a genuine kind of pub-sub architecture, especially when you have a one-to-many architecture, you could also flip some of the arrows and change the text. So here I'm saying that service A is publishing message to QX, and this thing is subscribing to messages from it. And I think that works better for the bottom diagram here, where we've got a genuine kind of one-to-many pub-sub thing going on. So don't be afraid to experiment with arrow directions and particularly the descriptions on the arrows. But yeah, essentially queues and topics as containers is the best way to model message-driven architectures. Shared libraries is another thing I always get asked quite a lot about. How do we model shared libraries and shared code in C4? Imagine you have a couple of applications, and those two applications are making use of a shared logging component which is coming from a shared library. So maybe it's on NuGet or Maven Central or NPM or whatever it might be. There's a temptation to model that shared library as a C4 container, because then you can have one version of that indicating it's shared and applications kind of pointing to it. X in the corner, no, this is not the best way to do it. So how do you show shared code? If you think about this from a developer's perspective, you've got two applications running, you've got shared code running here and shared code running here. So at deployment time, you actually have two copies of that shared code running in inside two separate applications, inside two separate container boundaries. So therefore, that's what you draw. So now we're showing we've got two application containers, and both of those have a copy of the logging component, which is shared code. Now, some of you might be thinking, well, this is not highlighting that those logging components are shared code, and you're exactly correct. So what you might want to do now is add a color coding. So maybe you add a color coding. I've used blue and gray. Other colors are available, of course, to indicate that these things are shared code. And of course, you make sure that this is present in your diagram key. If you want to add some of the other techniques I've already talked about in terms of organizational structures, we can now add a little bounding box around that logging component to say, hey, this is coming from a shared library shared library.jar file. So again, we're kind of mixing and matching some of these concepts here. Microservices. This is probably the area that I see a lot of teams really struggling with in terms of C4. It's unfortunate that one of the more popular software architecture books out there said this: C4 is more suited to monolithic architectures and doesn't support distributed architectures well. This is not true. I've had a conversation with the author. We have different opinions, but this is not true from my perspective. So how do people attempt to model microservices architectures? A lot of people start like this. They'll say, we're modeling microservices as containers with APIs and database schemas as components inside those containers. In the C4 model, components are not individually, separately runnable things. So representing an API and a database schema as C4 components doesn't fit the abstractions. And what's happened here is they've started one level too low, which has now forced them down more levels unnecessarily. So how do you model microservices? You have some options, unfortunately. So a microservice should be modeled as either a software system, a container, or a grouping of containers. Now I'm going to take you through a little scenario so we can see all of these things in action. So let's imagine we work for a small startup. We have 2 or 3 developers. We're all one team. We want to build a system, and we're going to build version 1 as a monolith. This is our context diagram. So our context diagram says we are building software system X. It's delivering business capabilities A, B, and C to our users. Nice and simple. Our container diagram, because we're building a monolith, it's a monolithic web application providing a monolithic UI, talking to a monolithic database schema. All good so far. Perfect. So now we've got some customers, we've got some traction, we have some money coming in. We're seeing some things start to slow us down in terms of having a single repository maybe. Maybe we've got some scaling issues. So we want to start now moving towards a microservices style architecture. Now this raises the question, what is a microservice? I'm going to fall back on the James Lewis Martin Fowler definition that you can find on Martin Fowler's website. And the thing starts out like this. In short, the microservice architecture style is an approach to developing a single application as a suite of small services, each running in its own process and communicating with lightweight mechanisms. I like this, but I want to C4 it. So I'm going to change one word. I'm going to say that the microservice architecture style is an approach to developing a single software system as a collection of smaller services. So our context diagram is the same. So in this example, we're still one team building all of the software inside this small startup. Our container diagram is now going to look different. So we're going to keep the monolithic web UI, and we're going to split out capabilities A, B, and C into separate services, each of which is going to have its own separate database schema. So each service is now essentially a combination of 2 things. It's an API thing, like a Spring Boot app, talking to a single relational database schema. Now in this example, I've used color coding to show there's a relationship between the various pairs of the elements. If you want to be more explicit, we can do the organizational thing once again. So here I've added some boundaries. We can see that service A is the top 2 things, B is the middle 2, C is the bottom 2. Imagine that our business is growing. We're now adding capability D to our system, and maybe capability D is implemented by a single AWS Lambda written in Python. It's the same thing as before, but now we have a single C4 container essentially being that service. Imagine this thing is totally stateless. It doesn't store any data. So this diagram shows you 2 of those options. A microservice is either a single container, like we have at the bottom, or it's a grouping of containers. So that knocks off 2 of those options right there. The assumption here, of course, is we're still one development team. Remember, the microservices architecture style is a way to develop a single software system with a smaller set of services. So I'm saying here all of these services live inside the software system boundary. We're all one team. We can change any of these services as a team. So now imagine we've got tons of money coming in, and we're going to do Conway's law. We're going to lean on microservices. We're going to start pushing microservices out of our team boundary. We're going to spin up new teams to own separate services because it starts to make things much more efficient. I'm going to remain on team X, building software system X, and I'm going to spin all the other services out into their own individual teams. My context diagram is now different. So my context diagram says I'm building system X, our users use my system, and I have a dependency now to these other services. So in this example, we're treating all of the services as separate software systems. You folks here are building service A, I can't see your internal implementation details. B, same deal, C, D, etc., etc. My container diagram is still the monolithic web application, but again, now talking to those external services mapped as software systems. If you folks have all joined Service A's team, your context diagram looks like this. This is your system, and you have an inbound dependency from my system. And when we zoom into your container diagram, it looks like this. So you are building that service comprised of an API thing talking to a database thing. So here we're using the software system abstraction as a way to describe a microservice, and really the heuristic here is team boundary. Can you see the implementation details? Micro frontends is an even longer story. If you are using micro frontends and you're struggling, my advice is look at the integration approach. Are you providing a set of JavaScript components accessible via NPM which are embedding into a page, or are you doing more of a kind of standalone single software system vertical slice iframe type approach? The integration approach will lean you in the right direction. Dependencies to external containers. So my recommendation is when you're drawing a container diagram, you only show containers inside your software system boundary. So for example, imagine I'm building a system called A, it's comprised of a Spring Boot app, and I have a dependency on something you folks are building which is called System B. This is my container diagram. I show my internal details, I don't show yours. From your perspective, you show your internal details. Maybe you have a Node.js API, and you have an inbound dependency from my system. You can't see my implementation details. I don't recommend mixing both these diagrams and coming up with something like this, where we're showing my container talking to your container. Why? Because now we're both aware of each other's details. If I rewrite my Spring Boot app to something else, your diagram has to change. If you split your single Node.js app up into two apps, my diagram has to change. So essentially, because I have some information about what you folks are doing, maybe we're one team. I think there's some additional coupling here that we're not talking about, and maybe we really should be one team. There are some exceptions to this guidance, which is stuff like shared databases. I know we shouldn't do integration via shared databases, but there's tons of software out there that does this. Imagine I'm building system A and I'm talking to your system B, but I'm going via a shared database so we can exchange data. The question you have to ask is who owns that shared database? If we can't make up our minds, maybe we just create an arbitrary system in the middle. The same is true of message-based architectures, by the way. If you have two systems and they are communicating via a queue, who owns the queue? Who owns the data format? Who owns the schema of the messages that go between the two systems? Answering that question will allow you to drop the queue into the right system context. If you can't answer it, maybe you've got something in the middle as a placeholder. A couple of last ones. Tooling. A lot of people say C4 doesn't scale, and for me this is a tooling issue. So imagine you have a microservices architecture. Here there are 8 services. Every service is a pair of an API thing and database schema thing. With 8 it kind of works, but imagine we started adding 9, 10, 11, 12, 20, etc. This diagram starts to get cluttered quite quickly. So how do you deal with this? Well, perhaps you draw one diagram per service showing the things coming into and out of that service. So you kind of restrict your point of view. With Visio, this is super hard. You have to figure out what's connected, copy all those elements out into a separate tab, and make sure you keep up to date. With my Sturcturizr tooling, because it's model-based, you can write a little expression and magic happens behind the scenes. A Service 2 version is exactly the same. The Service 3 version, exactly the same. So we're slicing and dicing the model and showing a subset, a partition of the information here. You could also use alternative visualization formats. So my Sturcturizr tooling supports a D3 force-directed graph. It's all interactive. This is showing you all of the containers that sit inside that software system boundary, but it's interactive, and it's a much more condensed, concise visualization format of those same concepts. You can click around, show nearest neighbors, there are tooltips, you can embed metadata. So you can embed metadata. So this is a much more suitable visualization style for exploring a complicated architecture. Similarly, you can dump this into other tools which allow you to navigate and visualize hierarchical data structures like ilograph, for example. And one of the final things is, well, C4 still doesn't solve our diagrams getting out of date. No, it doesn't. C4 is a set of abstractions, a set of diagram types, it's notation and tooling independent. So this is when you now need to figure out what tooling allows us to keep our diagrams up to date. In terms of system landscape and system context diagrams, what you want to do is really start bootstrapping and generating diagrams from data sources that already exist in your organization. So lots of people are registering services and systems on ServiceNow or Spotify's Backstage. Use that as your data source. Write some code, integrate with the Backstage API, pull down all the lists of services and systems and applications in Backstage, the links between them. Use that to generate your C4 system landscape and system context diagrams. Dropping down to container diagrams, these are a bit more tricky to generate automatically, but you could use parsing of log files, you could parse your build scripts, you could use open telemetry data, traces of other observability metrics as a source for identifying things running in the environment and the connections, events, messages between these things. When it comes to component diagrams, when we kind of zoomed into the boundaries of a single application, this is where you use traditional static analysis, reverse engineering techniques, either on compiled bytecode or source code, and you use that for identifying components and generating component diagrams automatically from a code base. And some of you are thinking, well, sure, that sounds all good, but how do you actually do it? So version 3 of my Sturcturizr tooling that came out a couple of weeks ago, this is all open source, it's all built on Java. Inside the Sturcturizr DSL, you can now drop this exclamation mark components block, and it will allow you to point the DSL at some compiled Java code and some source code. And in this case, we are identifying two very different types of components: web controller components and repository components. It figures out all the dependencies between these things, and that little bit of code generates this diagram from a real code base. So there are some things you can do today that allow you to kind of really use techniques in the real world. Similarly with deployment diagrams. Parse your Terraform, your CloudFormation, your AWS configuration, and use that to generate deployment diagrams. I have no tooling to do this for you, unfortunately, but it's, we're developers, we can probably build this ourselves. As a final note, something I've been doing with my customers recently is I'm trying to get them through the maturity model associated with software architecture diagramming. Lots of teams are here, they're doing nothing. Many teams are perhaps here, they're drawing those ad hoc diagrams that I showed you earlier. Just adopting C4 gets you to level 3. So we're now using a defined structured set of abstractions and diagram types, and you can get here with any type of tool, whether it's a diagramming tool or a modeling tool. To get further up in this maturity model, you really need to start adopting modeling tools. This is arguably the biggest leap. So you're manually all 3 models, and then to get to level 5, it's really about integrating with Backstage. It's about automatically generating diagrams from data sources. It's about querying. Maybe you drop the model into Neo4j and ask it questions. So there's a bunch of cool stuff you can do there once you get past the diagramming to modeling tool hurdle. And that's it. That's C4. Abstractions, diagram types, notation independent, and tooling independent as well. Thank you.